Hi, this is David, and this video is for an introduction to statistics. Today we'll be looking at an example of normal probability distribution. And what we're going to be using is we're going to be using a question from statistics class. And here's the question. An automobile manufacturer is interested in the fuel efficiency of a proposed new car design. 6 non-professional drivers were selected, and each one drove a prototype of the new car from Phoenix to Los Angeles. The resulting fuel efficiencies, X in miles per gallon, are the following. It's going to be 22.7, 29.3, 31.2, 28.4, 30.3, and 29.6. Okay, so part A is construct a normal probability plot for the fuel efficiency data, QQ norm on RStudio. Does the plot look linear? That's the question. Okay, so the tool we'll be using today for the normal probability distribution is RStudio to check whether or not the probability distribution is normal. Okay, here we are in RStudio, and now we're going to enter the data into RStudio. And you can follow along here. Okay, so it's going to be model greater than less than sign, minus sign C, and then you're going to put the actual data or numerical data in the parentheses. So it's going to be 27.2, and then you want to put a comma, and then you can either put a space or not put a space. It's not going to affect how this data, the final data, reads. So then it's 29.3, 31.2, 28.4, and then again, don't forget to put those commas in there, and then it's going to be 30.3, comma, and then the last numerical data is 29.6. And again, you don't need to put a comma on that last one. And then what you want to do is you want to just, after you have all that data in there, and you want to just push run. Okay, so now we're going to type in the QQ norm, and this is on RStudio. And then after you type in QQ norm, you also want to type in model. And then you're going to run this data. Okay, to see, after we've run the QQ norm, and this is to check to see whether the data is normally distributed. And as you can see by the chart here, there is a linear relationship between the z-score and the data values. Therefore, we can see that we have a normally distributed data. Okay, so on part B, run the distribution, run the Shapiro test on RStudio to determine if it is reasonable to think that the fuel efficiency distribution is approximately normal. So what we're doing here is, so what we want to do is type in Shapiro, and you can see it'll bring up a blue box, and you can click that, and that's just a nice shortcut, for those of you working in RStudio. And then what you want to do after the Shapiro test comes up, now all you have to do in the parentheses is type in model, because you already have your data stored and saved, and then all you have to do is hit run. And what you're going to do is the Shapiro test makes the assumption that the probability distribution has a normal distribution. P-valve is is that the Shapiro test calculates the probability of getting the sample we have in hand, assuming that we have a normal probability distribution. And as you can see, the results, which will be just down in that second box on the bottom of the screen, the p-value is 98.75%. And what that does is the assumptions that we made are absolutely correct. And then therefore we can make the assumption that the fuel efficiency distribution is normal, which answers question B.